So now that we know how to do confidence intervals for the mean, it's not too much different to do a confidence interval for a proportion. So basically, again, confidence intervals are giving us an estimate of where the population proportion would fall. Population proportion is symbol is pi. So many times we're interested in population proportions rather than the mean that we were doing before. Define pi to be the population proportion and small p is the sample proportion. This is what's going into it, but Megastat is going to do this for us. I just wanted to show you again, it's a sample estimate, so this is our sample proportion, plus and minus the margin of error. This z-score is going to represent the confidence, and then I'm going to have some sort of sample proportion or estimate of the proportion and the sample size. Okay, so this is kind of wordy, but bear with me. An American car manufacturer has a significant problem associated with windshield wiper motors. Each windshield wiper motor is typically evaluated on the basis of two quality characteristics, vibration and noise. We'll focus on noise, which is measured by an inspector who assesses each motor as either good or bad, based upon the noise generated while tested in the lab under conditions which have been shown to simulate the noise a customer would hear while driving. As a result, while noise level is an underlying continuous function, the data are artificially reduced to a dichotomous nominal variable. The current level of unacceptable motors produced based on noise level is too high and costly. Don't worry too much about the dichotomous nominal variable and continuous function. We're just basically getting to a proportion problem here for confidence intervals. So the current defect rate due to noise is 21.5%. Notice this is a proportion problem because of that percent. This is high considering it costs the company $51 per defective motor with annual production at 500,000 motors. Acme Inc. has come up with a solution. You have taken a random sample of 200 of the new motors and 21 of them to be defective. So notice 21 out of 200. That's something that can be calculated into a proportion. What is your point estimate and confidence interval for the new motors with a confidence level of 90%? So basically, with 90% confidence, where should my population proportion fall if my sample gave me 21 out of 200? Okay, so based upon these data, should the car company use Acme's new motors? Recall that the current defect rate due to noise is 21.5% and that the sample proportion is 0.105. Okay, so we have 0.105 and the current defect rate is 0.215 or 21.5%. Okay, so we go to Megastat, confidence interval sample size. This time click on the confidence interval -P tab, P for proportion, and you can either type in the 21 and it'll turn to an X, or you can type in the actual proportion. So you could have also just put in the 0.105 sample proportion. But let's just go ahead and, since the problem gave us 21 out of 200, once we type in that 21, it turns to an X instead of P here. So it starts out with the default as a P sample proportion, but once you put something that doesn't have a decimal, it'll turn to an X over N and divide it for us. Okay, so you plug in the X over N and the confidence level, and we have lower confidence about 6.9%, upper confidence 14.1. So yes, use the new motors. Even the high end of my confidence interval is lower than the original 21.5%. So with the Acme motors, I can be 90% sure that the defect rate due to noise for the population will be between 7% and 14%. That's much better than 21.5%. So even with the interval, the window there, it's still all below 21.5%. A recent a recent poll of 900 voters on early voting reported that 30% of all voters would vote early. Determine the 95% confidence interval. Okay, so I have 30% here. So I'm given the sample proportion, and I know that the sample size is 900. Okay, so add-ins, Megastat, confidence intervals, sample size, go to confidence interval for proportion. Make sure you put 0.3 in there for the proportion instead of 3, and then, or instead of 30. and then the sample size was 900, confidence level 95, and just hit OK, and you see that I can be 95% confident that the population proportion of early voters would be between 27% and 33% from here. Okay, 0.03 margin of error, 95% confidence. Okay, again, notice you can either put a proportion or the number out of the total, and it will calculate the proportion. So Megastat will adjust accordingly. You'll either see the default is P, so that it's looking for a sample proportion, but if you happen to put something like 20, it knows that that's not a proportion, so it'll make this X and then divide it to get the P. Okay. I can be 95% confident that the population proportion of early voters will be between 27% and 33%. Okay, a recent poll again of 900 voters. 30% all voters would vote early. Let's see now what happens when we reduce the confidence level all the way down to 80%. Since I'm giving up some confidence, I can include fewer values in my interval. Okay, all I did was change the confidence level, and I have a more narrow interval. So if my boss wants a more narrow interval, I tell my boss, well, I'm going to have to give up some of the confidence. Remember, an 80% confidence level means 10% chance of error. So I can be 80% confident that the population proportion of early voters would fall between 28% and 32%. Okay, a poll showed that 48 out of 120 randomly chosen graduates of a med school last year intended to specialize in family practice. What's the width of a 90% confidence interval for the proportion that plan to specialize in family practice? So here's another example of the type of problem, type of questions you might get about confidence intervals. I might ask, margin of error, what is the margin of error? So you would just report the half width that's given in the output from Megastat. I might ask for the confidence interval itself, or I might ask for the width of the confidence interval. There's two ways to do that. Just double the margin of error, or the half width, or just subtract the lower limit from the upper limit. Okay, so for this problem, the half width was 0.074. So I think the easiest way is to just double that, but you could also take the lower limit and subtract it from the upper limit to get the width of the confidence interval. Okay, so just talking about the chapter case and some decisions. Determine the sample size that will enable him to achieve a specified level of precision in his mean and proportion estimates. That was for the green cars example case at the beginning of the chapter. You can estimate the mean miles per gallon of all ultra-green cars with 90% confidence. Estimate the proportion of all ultra-green cars that obtain over 100 miles per gallon with 90% confidence. So those are the types of decisions that can come from the material in Chapter 8.